Welcome everyone to this presentation on Fit for the Future with hyperMILL, forward-looking manufacturing. My name is Nitin Jain, and I will be your presenter today for this exciting session. And as this session is happening for our viewers in India, aap sabko mera pyar bhara namaskar. So let's get started. The agenda for my presentation is I will give you a short company introduction, who is OpenMind, what do we do, with a general product overview of all the solutions that we have to offer. Then we will straight away dive into our today's topic, Fit for the Future. And in particular, we'll talk about 4 main technologies, which is MAXX machining, automation, additive manufacturing, and virtual machine, which is AKA digital twin. Well, OpenMind Technologies has been existing for last 25 years plus. Last year, we celebrated our 25th anniversary. Our corporate headquarters, and you can see our office out there, is in Westling near Munich, Germany. There are about 350 employees. We are spread out globally with about 15 subsidiaries and 40 resellers. OpenMind is a wholly owned subsidiary of Man Machine, and our main product is hyperMILL, which is a CAM software. We have sold over 20,000 licenses worldwide and have more than 7,000 customers globally. As I mentioned, our presence worldwide is very global. About 15 direct subsidiaries of OpenMind supporting in different parts of the world. And all the flags that you are seeing there is where our direct offices are. Plus, we have many resellers that are selling hyperMILL as well. Specifically for India, OpenMind Technologies India main office is in Bangalore. We have many satellite offices where our people are spread across the country in different cities like Pune, Ahmedabad, Coimbatore, Kochi, and Noida. And we have a direct sales force that is also supporting all our customers. With all these icons you are seeing are some of our customers in India that we have been supporting for many, many years. hyperMILL is sold and used in all types of industry types, whether it is aerospace industry, medical, mold and die. We also have very specific solution for turbo machinery, like development of various compressors and turbines, automotive, you name it, can do all types of milling and manufacturing with hyperMILL. OpenMind is a very strong team player, and we have many partners throughout the industry, whether these are machine tool partners or the software partners or various controllers and the cutters as well. And this slide kind of gives you a glimpse of all the people around the world that we are working with, and hyperMILL can talk to their various products as well. Now let's come to the product overview. hyperMILL is a modular and a flexible CAM solution, starting from 2.5D, 3D, all the way up to 5-axis milling, mill turn, and machining operations such as high-speed cutting and high-speed, high-performance cutting. All this is integrated in a single interface. We also offer unique modules like for turbo machinery, as I mentioned, for machining of impellers, bliss, single blade, complete machining for milling and mill turn in single interface and single post processor results in an integrated processes and minimizes machining time while also increasing reliability for maximum process reliability, cost efficiency, and quality. So you can see all the technology is listed there. And yes, we have our own CAD solution, which is CAD for CAM or HyperCAD S. But hyperMILL is also available as an integrated solution to run within SolidWorks as well as Autodesk Inventor. Now let's talk about today's topic, fit for the future. So as I mentioned, we'll be talking about first about our milling strategies, and under that, very specifically, we'll talk about MAXX machining. Speed is of an essence, and in today's competitive world, more than ever, it is a key purchase incentive. And MAXX machining is a performance package for drilling, roughing, and finishing that saves tremendous amount of time. This allows CAM programmer to maximize machine performance for any application. The second thing that I will be touching upon is automation. It is a buzzword in the industry right now. Yes, with the hyperMILL Automation Center, one can standardize and automate complex processes, process flows, and functions from within our CAD to CAM, what we call HyperCAD S and hyperMILL. So there is a basic automation that is available in the base package of hyperMILL itself. So one can, out of the box, can start using our automation functionality. I will be touching upon that. Third thing that I will be talking about is additive manufacturing. Again, very sought about subject. Additive manufacturing offers many new possibilities, and in order to fully exploit its potential, an innovative CAD/CAM solution is an essential part. So the strategies and reliable simulation of material application and removal provided by hyperMILL, it offers a perfect toolkit for fully exploiting the vast potential of hybrid manufacturing, and I will be showing you that. And finally, the fourth topic, again, very talked about subject under Industry 4.0. I'll talk about our digital twin, what we call virtual machining. So components are becoming more and more complex, yet turnover time keeps on getting shorter. So as a result, manufacturing companies must take optimum use of their machines while preventing auxiliary process times or production downtime. And hyperMILL Virtual Machining Center is a true NC simulation that generates a particular virtual rendering of reality in the machine. So this networking between the machine and hyperMILL enables unmatched process control and safety. So let's talk about our very first topic under Fit for the Future, that is MAXX machining technology. Okay, so MAXX machining allows for what we call maximum speed in all application areas. It is a performance package for drilling, roughing, finishing, that serves as a tremendous amount of, that saves you tremendous amount of time. And while still delivering top quality. And this allows CAM programmers to maximize machine performance for any application. So here in this video, you can see max finishing of an aerospace structural part. And that is what we are showing in this video. Also, in the bottom left hand, what you're seeing is again an aerospace structural component that has been machined from a solid block, 27 kg solid block, and the finished part is just 1 kg, and this has been machined in just 75 minutes. So that means 95% of the material has been removed in 75 minutes using this MAXX technology, without compromising on the quality. So on the right, what you're seeing is again an automotive mold, and you can see the quality of that part. So high quality surface finish, improved process stability, increased cutter life. All these are the benefits you get from MAXX technology, and you can save up to 90% of the time. So like I said, MAXX technology is available for roughing, drilling, finishing, and turning. So MAXX roughing, optimized pocket strategies, and tropoidal tool paths ensure extremely fast material removal. So this technology can be used for multi-axis milling, HPC, and high-speed cutting gives enormous time savings for exotic materials like what are used in aerospace application. MAXX drilling is a very innovative way of drilling under like helical drilling or helical tilt machining. Milling cutter is tilted towards in the direction of the motion, and the second inclination plane helps to avoid collision with the bore walls. So 5-axis helical drilling eliminates the need for any pre-drill. Under MAXX finishing, we have innovative strategies for barrel cutters that allows finishing to take place in record time. And I showed you in my past slide for an automotive mode. As you can see in this video, again, this is an engine casing for an aerospace application. MAXX turning is being used for high performance turning. 3-axis simultaneous turning is also available for complex turning profile in hyperMILL. Okay, now moving on to another topic separately under barrel cutters. Yes, and this is especially for under MAXX finishing. We can support different type of barrel cutters, such as a general barrel, tangential, conical, lens type cutters, and so on. These tools can be defined within hyperMILL, a tool database, and are completely collision checked. Unique features are available to handle conical barrel cutters for plane and curved tangential surface, which gives less machining time, again without compromising on surface quality. And as you can see in my slide, the difference between using a ball mill versus a barrel cutter. And with the barrel cutter, you can see that we can have a higher step down, can be achieved along with, again, better surface quality. The use of barrel cutter ensures increased tool life, better quality, and like we said, time savings up to 90%. These are some of the applications you can see here that we have used MAXX machining for medical parts, aerospace parts, and mold and die parts. Now, under second topic, automation center. So why automation? I mean, automation has many benefits. Of course, the very first thing that comes to everybody's mind is reducing the programming time, machining time, assembly time. But yes, you can reduce errors, rejections, setup time, uh, tooling costs, number of tools that have been used. The benefits are enormous when you start doing automation. And yes, to do this, there has to be highly productive synergy between your machine tool, the CAM software, and the tool. So under automation, hyperMILL offers what we call feature macros. With hyperMILL features, numerous automation options are available that can minimize your programming effort and also lower your machining time. And under feature macros, the software can automatically detect features like holes, slots, pockets, and so forth, and that can really reduce the programming time. hyperMILL also offers what we call, this is very unique in terms of automation center, where this technique is using all the information from CAD, CAM, tool database, macros like the color database. So it is using all this information collectively. And hyperMILL facilitates full and partial automation transfer of tasks from people to software. So the processes that run automatically in the background can be generated, okay, and that can greatly simplify even the most complex programming tasks. Okay, and the CAM programmer directly benefits from simple, convenient, and very time-saving workflows. And we will show you that with an example. So here is an example, and in this example, we are using our basic automation commands available in the hyperMILL, basic version of hyperMILL. The standard templates run major commands listed here that you can see. And once the script is started, for this, here we are using an engine casing again. All features will be recognized and jobs will be optimized and calculated. So you can see here, now you'll see macros being recognizing the holes and jobs are being added. And this automation process can be used for repeating programming of parts which have similar geometric features. So with this automation feature, you can even generate reports, automatic reports that you want. So let's look at the simulation of calculated jobs. 5-axis helical drilling shows complete control of machine movements. Centering job shows linking of each pocket as well. So you can see all these things in this very nice example of engine casing, where automation has been done with the basic version. So we have not still used the advanced version of hyperMILL Automation Center yet. Okay. So our third topic, as I mentioned, is additive manufacturing. So hyperMILL supports two types of additive manufacturing. First is DED, direct energy deposition, during which material is fed as powder or wire and melted directly onto the component using a heat source. And we also support powder bed fusion that involves generating components on the powder bed through imprinting in layers. And for both these methods, there are various strategies that are available. And again, complete collision check is carried out for all components that are involved in the process. Okay, so hybrid manufacturing is a perfect way of carrying out local limited repair on worn or damaged areas, such as tooling or sampling of stamping of like turbine blades, and that can be done in a very short amount of time. And with the 5-axis simultaneous process, these complex parts can be manufactured, and it also provides optimum tilt needed for the nozzles for material deposition. So majorly this additive technique is used for building of new parts, repairing, and for modifying existing components. So here in this video, you can see the example of a propeller being manufactured using additive technique, DET, and below you can see the repairing of a blade. Okay, so what industries can benefit from additive manufacturing? Pretty much you can see most of the industries can benefit from, and clear advantages. By using this technique, you can combine different materials to enhance the properties. Complex geometries can be produced, like cooling holes in a blade. And minimal material is used, again, by reducing that reduces your stock inventory, easy to change or revise parts, and repairing of damaged components, as we have seen. Okay, so again, some of the application examples that we have demonstrated with hyperMILL for additive. As we mentioned, completely new components with complex features can be built, okay, with a mix of different materials. Additionally, you can add geometric features that needs to be added on an existing part or reworked. Parts can be reinforced in certain areas by adding material there, or surface properties can also be changed in a targeted manner. Also, this is a best technique for repair and rework of damaged areas, and part repair, you can see, as we showed before, can be seen for turbine blades that are refurbished. So many different applications, what we call to build, modify, and repair of components. Okay, my final and fourth topic is virtual machining, what we call the digital twin. So this is a state-of-the-art technology, which is an important step towards a smart factory. So hyperMILL virtual machining plays an important role for NC simulation, machine movements optimization, and real-time control of machine remotely. So hyperMILL virtual machine offers complete bidirectional connectivity for the real and the digital world of CAM. So CAM system is operated with the virtual machine module, which is equipped with the integrated post processor, and this in turn is also connected to the real machine. All the connections are bidirectional, and the data is transferred without any data loss. Each machine, as we know, is unique, and therefore every digital twin or virtual machine is also unique. Okay, so with a virtual machine, you can evaluate, control, and optimize machining processes more effectively and reliably. So this virtual machine contains three major modules: virtual machining center, optimizer, and connected machines. And all these three combines together makes the digital twin. Virtual Machine Center for NC code simulation and toolpath or machine analysis, optimizer for automatic NC code, machine movements, optimization for the machines, having axisymmetric spindles or even for general 5-axis machines. And then finally, connected machine for bidirectional connectivity, which reviews the critical parameters and operate the machine remotely. So with the laptop sitting in different part of the world, you can operate your machine located in India. So this is a very time-saving process, as all machining processes can be simulated in advance and analyzed in detail to optimize setup and things like retraction processes. So what we see is what we check is what you get. Okay, so with hyperMILL digital twin, 100% identical machine is available in the virtual world. Okay, so there is a virtual sibling for each physical component. So these are the 4 components. The virtual machine represents the machine tool with all its kinematic components, all axis limits, and the workspace. The virtual PLC component represents all the machine movements due to the PLC commands. The virtual CNC gives the user interface to VMC. So it drives the virtual machine like a normal machine tool with manual data input, jogging, start-stop program. In addition, it also allows to do graphical axis analysis, collision check, and dynamic stock removal. The final piece, virtual NC code, is the most important one of the most important one. Everything is important. It creates NC representation that contains all usual NC formats. So therefore, we can machine the hyperMILL generated NC code. So finally, what we see is what we check is what you get, 100% identical. So here is an example of virtual machining. As you can see, showing a 5-axis deburring operation, or again an aerospace structural part, and the machine tool being used is a probe machine. And all the linking movements that you're seeing are in red color, and the complete spindle movements that you're seeing is in blue color. On the right hand side, you can see NC block that is running each line, and clear program management is available with all the subroutines. And below the NC block, you can see a controller option to completely control the machine, your feed rate, speed, and the movement. So that is why we call it, 100% identical, and you can visually see everything, how it is going to happen on the machine. Okay, so this is my final slide. So in summary, that is why we call that hyperMILL is fit for the future. It is the forward-looking technology for people who are looking at utilizing their manufacturing assets not only today but also in the future. hyperMILL, or we can say OpenMind as a company, is a pioneer and enabler from the start of its foundation. As you know, we are the world leading 5-axis technology provider. And yes, we are fully committed to finding and providing the best solution to our customers. And the proof of all that is what I've showed you in short glimpses of 4 technologies, whether it is milling strategies with MAXX machining, automation, additive manufacturing, and the digital twins. So that makes your investment future-proof with hyperMILL. With that, I finish my presentation, and I will be happy to take a few questions, time permitting.
Thank you, Mr. Jain. Dear participants, if you have any questions, you can now enter them in your question box so that Mr. Jain can answer them. Thank you.
Okay, well, if no questions, and maybe if you do have questions in future, please feel free to reach out to us. You can find a lot of information on our website, and there you can find information that you can download. There are many videos that are available. We have a very nice a YouTube channel for Open Mind Technologies with many videos, even the ones that I showed today in my presentation. Feel free to have a look at it. Also, you can contact me directly as well through email. My email is nitin.jain, my full name, at openmind-tech.com. Okay, so seems like no questions so far. With this, I would say thank you so much for attending today's presentation. And all of you have a good rest of the evening or afternoon, wherever you are. Goodbye. Thank you.